Okey, dulu saya lah. Okey. Ya, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Sebelum kita mulakan majlis, kita baca umul kitab Al-Fatihah. Auzubillah. Alhamdulillah, bersyukur kita kepada Allah SWT. Pada petang ini kita dapat menjalankan sesi Kolokium pada bulan Oktober 2022. Dan untuk petang ini kita ada 3 pembentang. Pembentang yang pertama adalah Dr. Nur Hanimah Khamis. Jadi latar belakang, serba sedikit latar belakang Dr. Hanimah telah memperoleh Bachelor of Science daripada UiTM Shah Alam, Master juga daripada UiTM Shah Alam, Master by Research. Manakala PhD beliau adalah dalam bidang Fuzzy Analysis daripada University of Manchester, UK. Jadi tajuk pembentangan Dr. Hanimah pada petang ini ialah Interdependent Relationship of Criteria in Similarity Social Influence Network Group Decision Making Model. Jadi tanpa melengahkan masa lagi, saya mempersilakan Dr. Hanimah untuk membuat pembentangan. Dipersilakan Dr. Hanimah.
Okay, thank you Dr. Agus. Let me share my presentation first. Boleh nampak ke?
Nampak.
Okay, alright. So, Assalamualaikum and good afternoon to everyone. Thank you to Dr. Agus and other committee members for organizing this Kolokium. So, I am Nur Hanimah Khamis, and the title of my presentation today is Interdependent Relationship of Criteria in Similarity Social Influence Network Group Decision Making Model. Actually, this work has been presented in Computational Models and Technologies, CMT 2022 in Uzbekistan. So let us start with group decision making. So this is the formal definition for group decision making. But as we know that in group decision making, of course, we have a group of experts, or we can call as decision makers. So a group of decision makers or experts will discuss on how to get a collective solution regarding a certain decision problem. So the next one is social influence network group decision making. So when we have group decision making with social influence network theory, so we call that one as social influence network group decision making model, SIGDM. And of course, for the influence network, we have a process of intrapersonal and interpersonal interaction before the decision making has been made. Intrapersonal is the interaction between inside the group or inside the decision making, and then the interpersonal is the external factors that can be influenced their decision in the decision making. This is the previous research by Khamis et al. 2019. We include the influence-driven feedback mechanism. Sorry, we include the influence factor in the feedback mechanism. In this paper, we bridge the gap between social network analysis, social influence network, clustering, and trust-based concept. However, this is the research flow for the previous paper that I mentioned just now. Okay, for this work, for this paper, we improve our work in Khamis et al. 2019 by considering the criteria and the interdependent relationship, which are not taken into consideration in the previous one. So in this paper, we overcome the absence of the criteria and the interdependent relationship by integrating the cause-effect visualization that is inspired by the De Martel procedure. So we start the proposed methodology. Okay. So of course, as I mentioned previously, in group decision making, of course, we have a group of experts we call as E1, E2 until EM. And then in this work, we consider the criteria or factors, which is C. So this methodology, we have two phases. The first one is the similarity social influence network group decision making model, and we have the other part, which is the improvement of the previous work. So for phase one, we have step one. We evaluate the criteria based on the reciprocal fuzzy preference relation. So based on definition 2.1, let's say we have Pij equal to 0.5. The evaluation equal to 0.5, meaning that criteria I and criteria J are equally preferred or indifference. Okay, if we have the value between 0.5 to 1, meaning that criteria 1 is slightly preferred to criteria J, and if Pij equal to 1, Ci is absolutely preferred to Cj. Criteria I is absolutely preferred to criteria J. So this is the definition for the reciprocal fuzzy preference relation. Okay, the next one, we have to transform the reciprocal fuzzy preference relation into the intensity preference vector. This step is important to make the computation more simpler rather than having a very big number of matrices. Then we transform into the vector form. Okay. So the next one, step 3, we determine the expert preference similarity index. When we have two experts, expert A and expert B, so we want to find the similarity of their opinion regarding the decision problem. So we can use the cosine preference similarity index that I show here in definition 2.4. Okay, the next one, based on the similarity indexes, we can construct the similarity social influence network SSIN. The social influence network SSIN is an ordered 3 tuple which consists of E, which is a set of expert nodes or set of decision makers node, and then we have the link L, and then we have the similarity weights S sub eta. The next one, we find the influence index of expert. Okay, influence index of the expert is measured using definition 2.6. So we have Y equal to I minus sigma S sub eta transpose inverse Z. Okay, for this one, as we have in the bracket, the measurement represent the internal connections, or we call as the relative importance of endogenous, or in bahasa biasa we call as internal relation or influence. And for the external factor, it represented by Z. So for this influence index formula, we consider both internal and external measurement. Step 6, we aggregate all individual experts into a collective one. It is the same as if we have a simple average. But for this one, we use a sigma Iowa operator. So we enter the next phase, visualization of interdependent relationship of criteria. So in step 7, we determine the initial direct relation matrix, and we define that this X is come from the influence-based collective preference matrix PC in phase 1. So the next one, we normalize the initial direct relation matrix. Of course, for the normalization, it is important to map the Xij to 0 to 1 value. The next one, we find the total relation matrix. Total relation matrix meaning that we sum up all direct and indirect influence values. So the next one, step 10, we compute the sum of row and columns. Sum of row is Ri, and then sum of columns is D sub J. So R sub I represent both direct and indirect effect given by criteria I to the other criteria. And for sum of columns, D sub J summarize direct and indirect effects by criteria J from the other criteria. So step 11, we construct the cause effect diagram of criteria based on the sum of row and sum of column. So the cause effect diagram can be constructed by mapping the data set in XY axis based on the value of R sub I plus D sub J and R sub I minus D sub J. So for R sub I plus D sub J, values represent the total effect given and received by criteria I, and then the value for R sub I minus D sub J shows the net effect that criteria I contributes to the system. Okay, the next one, the last step is finding the ranking of the criteria or factors. So the importance of the criteria or the influence factors, the strength of the influences can be measured by ranking of the R sub I plus D sub J values, which is in x-axis. So this is the numerical example. As I explained in the methodology part, the evaluation of the criteria is in terms of reciprocal fuzzy preference relation. So now we have 8 experts or 8 decision makers, and the evaluation is based on reciprocal fuzzy preference relations over 7 criteria. That is why we have 7 times 7 matrix. And this is the results. The first one, we visualize the similarity social influence network SSIN that consists of 8 experts, and the values that we can see here is the influence degree or the influence index that we have, and we map into the network figure. And based on table 1, we have the sum of influence cause and effect on 7 criteria. As I mentioned before, the R sub I plus D sub J is the degree of importance of criteria. So R sub I plus D sub J will be shown in the x-axis. And then, of course, as we can see in figure 3, we have the biggest, the highest value is C2, meaning that criteria 2 is the most important criteria in this decision-making model. And for R sub I minus D sub J, it maps the values in y-axis. So based on table 1, we have we can see that we have positive value and we have negative value of R sub I minus D sub J. So for y-axis, it represents, all values represent the impact values or the relation values. These values show the degree of a factor or criteria influence on the system. So for the positive values, we can see in figure 3, we have positive values. For the criteria, we have criteria 5, 6, 7, 3, and 2. So all these criteria have positive values for R sub I minus D sub J. So it is a causal variable. Causal variable means that these criteria can influence other criteria. So, and then we have C1 and C4 with negative values in y-axis. So these two criteria represent the effect variable. So meaning that these two criteria is being influenced by other criteria. We call that one as effect variable or net effect variable. Okay, so the final step is the ranking of all criteria in descending order. So we know that from R sub I plus D sub J, the highest value is criteria 2 and the lowest is criteria 5. So criteria 2 is the most important criteria in this decision making. Okay, so the conclusion, we achieved two objectives in this work. So we already include the criteria or factors in the experts evaluation, and we visualize the interdependent relationship of criteria by constructing the cause effect diagram inspired by the DeMartel method. So for future work, rather than cause effect diagram, we can use other visualization technique. For example, we can use multi-dimensional scaling, or we can use clustering algorithm, and so on. And of course, in this work, we only use the hypothetical example for the implementation. But for future work, we can use a real life application to implement the proposed model. So these are the references used in this presentation. So thank you. That's all.
Terima kasih Dr. Hanimah. Jadi sekarang kita buka untuk soal jawab. Jika ada soalan daripada pelayar semua, mungkin boleh bertanya pada Dr. Hanimah. Kita ada 3 pembentang. Pembentang pertama Dr. Hanimah dibuat secara live, manakala pembentang kedua dan ketiga hanyalah melalui video sahaja. Jadi untuk pembentang bertanya, kita boleh tanyalah soalan kalau ada secara live. Ada soalan? Okey, nampaknya tak ada soalan Dr. Hanimah.
Tak apa, no problem.
Okey, pembentang secara video ni, pembentangnya adalah Dr. Nurmi Abdul Hadi. Jadi latar belakang Dr. Nurmi ni, degree daripada Universiti Sains Malaysia tahun 2005. Master juga daripada Universiti Sains Malaysia 2006. Manakala PhD beliau daripada UiTM 2015. Tajuk pembentangan beliau melalui video bertajuk a 3D point cloud filtering algorithm based on weight eigenvectors in principal component analysis and region classification. Jadi untuk membantu pembentangan secara video ni, saya mohon Dr. Suhaila untuk memvideokan benda tersebut.
Assalamualaikum and good evening to all of you. So first of all, I'm sorry because I cannot present my research in live because I have another event, AKNC Anjung Seri Budiman. So the title of my presentation is a 3D point cloud filtering algorithm based on weighted eigenvectors in principal component analysis and region classification. Okay, so these are the list of authors for this project. Okay, my student Farah Izzati, me, Dr. Suhaila, and also Dr. Norma alias from UTM. Okay, so this is the outline of my presentation, introduction, some literature review, result and discussion, and also conclusion and recommendation. Okay, so what is 3D point cloud? It is a group of data point in 3D coordinates. Okay, usually it is represented in X, Y, and Z. So the use of the point cloud is to describe an object external surface, and we can obtain the data from various data sources such as laser scanners, photos, and also videos. So what is denoising? So noise refers to the unwanted data that degrades the image quality. So the 3D denoising is a part of 3D point cloud processing. Okay, it is to remove outliers and also to produce a high fidelity output. Okay, so besides, the 3D denoising can be used to preserve the geometry sub-features. Okay, so what is the motivation for us to do this research? It is to preserve the important features because while we are denoising the 3D point cloud, okay, so we need to preserve the important features, and then we will use the weighted PCA introduced by GIA 2019. And we want to improve the method by GIA by introducing the weighted eigenvectors, which is introduced by Salaria in 2020. So this is the framework. Okay, first we will do the data acquisition, and then we will put some noise. So it is called as data corruption. And then we will do the denoising process, regional classification, and also the performance analysis. So this is the data acquisition, the 3D point cloud. Okay, so in this research, we use the box, Stafford Bunny, and also pipe curve model, which is available, free data available in the Point Linet database. And originally, this data does not consist of any noise. It is in 3D format. Okay, and then since each data set consists of 100,000 points, which a usual laptop cannot carry, so we reduce the data to 5,000 points randomly. Okay, and then we do the data correction, which is include the noise into the data set. Okay, so we are using the Gaussian noise given by this one, W equals to S plus N. So actually this is X, Y, Z. Okay, and in Gaussian noise, we can choose the percentage of the noise that we want to include. Okay, so this percentage will move the original point to a new position. Okay, so the larger the percentage is, the further the point will move. Okay, and then after the data corruption, so we do the region classification. Okay, so this is to differentiate the denoising method that is suitable for a certain region. Okay, so we use the normal vector. Okay, so the region will be split into flat and mutant. And for flat region, we will use median filtering. And for mutant region, we will use bilateral filtering. Okay, so first of all, we calculate the principal component analysis, or called as PCA. Okay, so the normal PCA used by a lot of authors is given by this one. Okay, but we use the weighted PCA introduced by GIA. Okay, so C here is the covariance matrix, P here is the mean of the neighborhood, and PI here is the data point. Okay, so for weighted PCA, the matrix C here now is called as CW, where W is the weight calculated by this formula. Okay, and then from the matrix C in the previous slide, we can calculate the eigenvectors and also the eigenvalues. Therefore, this research use weighted eigenvector, where the obtained eigenvector from the matrix C previously, okay, will be multiplied with some weight. Okay, so the reason for these weighted eigenvectors is to lower the effect of the normal. And then the weight of the eigenvectors is between 0 and 1. Okay, so next step is the region classification. From the obtained eigenvalues from the matrix C, PCA matrix C, okay, so we can use this equation of sigma to calculate the sigma P for each data point. Okay, and then we will use this data to classify based on the sigma value whether that point belongs to the flat region or belongs to the mutant region. In this case, the blue points is the flat region and the red points are the mutant region. Okay, and then the denoising process is done separately between flat and mutant region. Okay, so for flat region, we will use median filtering. Okay, again, this is an improved median filtering. Okay, so this is the formula of median filtering. Okay, so the number of data points before and after the denoising process is still the same. Okay, in our case, we use 5,000 points. So originally we have 5,000, and after the denoising, the number of points is still 5,000 because the denoising, the definition of denoising in this research is moving the position of the point to a new one. Okay, so this is the new position, this is the old position, and we will plus with a project mid, which is the distance of the sampling point P moving along the normal vector N. Okay, and for mutant region, we will use bilateral filtering. Again, the purpose or the process of the denoising is we need to move the noise to the some position, which is it should improve the representation of the data. Okay, so this is P new is the new position. It is P the old data plus A. So A is given by this equation, and then these are the parameters inside the equation. Okay, again, bilateral is to smooth the mutant, and median filter is to smooth the flat region. Okay, so for result and evaluation, we are using two parameters, actually three: the mean, delta, and also the processing time. So the mean represent the average distance between the resulting point and also the ground truth, which is the original data without noise. Okay, and then this is after resulting point is a point after denoising, and delta is average angle. Okay, if d is the distance, delta is angle, and also we consider one more parameter, which is the processing time. Okay, so since we have three data set, okay, so this one is for box. Okay, so as we can see, we have three columns here. Okay, the last column is all PCA, meaning that we use PCA without weight. Okay, without weight. And GIA here is the weighted PCA, and the GIA salaria is the weighted PCA plus together with weighted eigenvector. So this is what we did in this research. Okay, we improved the GIA by introducing the weighted eigenvector, and we call that one as GIA salaria. Okay, so the highlighted cell here represent the best value. So as we can see here, the best performance are given by the GIA salaria, which is the method proposed in this research. Okay, the weighted PCA plus the weighted eigenvector. Okay, we use different KNN, which is the K neighborhood. Okay, and then we also use different variable, a different parameter B, which is in the bilateral. Most of the best result are the GIA salaria, okay, which is the method proposed in this research. Okay, this is for the box. Okay, and then we also tested on different Gaussian noise. Okay, and still GIA salaria give the best result. Okay, so this is for box model. Next, we have bunny model. Okay, so similarly, GIA salaria give the best performance for all KNN, for most KNN, and also for different variable B. and also the different percentage of noise. And also for pi, okay, Gia Salaria, okay, most of the best values given, most of the best result given by Gia Salaria, okay, with different KNN, with different value of B and with different data percentage. Okay, and then we also tested with using the different eigenvector weights, okay, R just now. So R is between 0 and 1. So in this case, we compare R 0.25, 0.5, and 0.75 for this value of B and KNN equals to 1, and the noise is 2.5%. The purpose of this comparison is to analyze whether the bigger or the smaller R will give us the best result. And then from this table, we can see that the smaller value of R will give us the best result. Therefore, it shows the significant weighted eigenvector that is that introduced in this paper. Okay, so we should lower the effect of the normal vector in 3D denoising. Okay, so for the conclusion and recommendation, okay, so this research has improved the normal estimation, okay, by using the weight of eigenvector. And for future research, okay, maybe we can consider other features such as color and also geometric data. Okay, so that's all from me. Okay, if you have any question, you can freely contact me through this email. Okay, thank you.
Okey, itu tadi video presentation daripada Dr. Normi. Jadi kepada sesiapa yang berminat untuk bertanya dengan lebih lanjut, bertanya dengan lebih detail berkaitan dengan kajian beliau, bolehlah berhubung terus dengan Dr. Normi ya. Sebab di sini Dr. Normi tak boleh nak jawab soalan sebab beliau ada urusan lain, yang tadi itu hanyalah rakaman video. Okey, jadi untuk pembentang seterusnya, yang ini special sikit ni. Pembentang ketiga ni adalah student undergrad kita, Sharifah Noha Zahirah binti Syed Abdul Nasir dan Nurul Ain binti Abdul Wahab. Hasil kerja mereka berdua ni telah memenangi peringkat perak baru-baru ni di FIF 2022. Jadi atas saranan pihak Kolej untuk mereka berdua ni untuk masuk IIDEX 2022. Jadi mengikut syarat IIDEX 2022, video pendek yang dikendaki adalah lebih kurang 5 minit sahaja. Jadi video yang dibuat oleh Sharifah Noha dan juga Nurul Aini lebih kurang 5 minit sahaja. Jadi mohon pandangan dan nasihat ya, kalau boleh ditambah baik video mereka berdua. Semoga dengan penambahbaikan yang mungkin kita cadangkan akan membolehkan mereka berdua memenangi peringkat di IIDEX 2022 nanti. Okey, jadi saya mohon bantuan Puan Salmah untuk membuat paparan. Dipersilakan Puan Salmah.
Assalamualaikum. We are from Bachelor of Science Mathematics from College of Computing, Informatics and Media UiTM Shah Alam. We are going to introduce to our project entitled Solving Nonlinear Equations by using Graphical User Interface for undergraduate student. First of all, we are from group Meet and I'm one of the member. My name is Nurul Ain Abdul Wahab and my partner Sharifah Noha Zahirah Said Abdul Nasir. For the head of this project is Dr. Muhammad Agus Salim Nasir.
I will now start by stating our problem statements. Solving nonlinear equations can be challenging since the process is repetitive and needs a tedious work. Nonlinear equations can be solved using a few numerical methods, for example, bisection method, secant method, graphical method, and Newton's method. These methods consist of iterative procedure and can be tricky since the process needs to be repeated many times and a long calculation is needed. However, there is a limited number of softwares or applications that can be used to solve these equations and for students to check whether their answers are right or wrong. The objectives of this innovation are first to develop a system that can find the root of nonlinear equations based on the input key in by the user. Second is to display the approximate root in a graph, and third is to help students to check for their answers easily. This innovation is basically a graphical user interface GUI and will be developed through MATLAB with the usage of App Designer, which is embedded in the MATLAB and will involve some coding skills. In this GUI, the user will be able to input their nonlinear equations and choose their preferred method to solve the equation. The end product is hoped to be able to achieve the objective and address the state problems.
This is the flowchart on how the system will be functioned, where firstly, the user need to insert the function and interval as the input, and after that, they need to choose either one from 4 numerical methods provided, which are graphical, bisection, Newton's, or secant method. And then the system will calculate and produce the approximate root as the output.
I will now show the simulation of our innovation. Before that, I am going to show the manual calculation. Let's say we have this question with the function exponent to the power of x plus x minus 2. We want to know the existence of the root in the interval 0 to 1. After we calculate it manually, using the right iteration, the estimated root correct to 3 decimal places is 0.443. Now I am going to show you how we get the answer using our product. So this is the prototype of our GUI. I am going to input the same function as earlier, which is exponent to the power of x plus x minus 2, and the interval is from 0 to 1. And I am going to pick bisection method as our method to solve this question. And when I press the calculate button, the estimated root is shown here, which is 0.442856, and it is equal to 0.443 if we round up to 3 decimal places, and it is the same as what we calculated earlier.
The significance of this project is, with the existence of this simulator, will give more benefit to the student that learn mathematics subject. This is because with it, they can check on the answer to the question anytime they want with just only a few steps. Moreover, with the graph provided, will give more understanding for the topic that they learn with the way of illustration. In conclusion, in this era of globalization, the usage of technology has been expanded in many sectors, including education sector. So, if the simulator can be improved by including another topics in mathematics subject, it can give benefit not only to students but also to the lecturers.
Okey, jadi itu tadi video pendek daripada pelajar kita, Sharifah Noha dan juga Nurul Ain. Mereka adalah daripada CS249. Tadi tajuk pembentangan beliau sebenarnya saya terlupa tadi, Solving Nonlinear Equation by Using Graphical User Interface for Undergraduate Students. Jadi kepada rakan-rakan mensyarah yang sebelum ni pernah masuk pertandingan invention di mana-mana, mungkin boleh bagi pandangan atau nasihat untuk menambah baik kajian ataupun dapatan yang diperoleh oleh mereka berdua. Kalau ada, mungkin boleh share, kongsi, mudah-mudahan bantuan kita kepada mereka berdua membolehkan mereka memenangi medal di IIDEX 2022. Jika ada pandangan, mohon ajukan.
Assalamualaikum Dr. Agus.
Ya, saya.
Jika ini cuma sedikit added value jika ada lah. Jika dah publish paper ada tajuk yang berkenaan dengan sikit-sikit lah yang ada dengan tajuk yang student ni buat, boleh letak dekat situ yang paper yang dah publish tu, dia punya first page tu lah. Selalunya saya rasa kalau publish paper, bila kita dah buat innovation ni, kalau kita dah publish dulu, dia ada added value kat situ.
Maksudnya kena tambahkan kan berkaitan dengan pembentangan yang terdahulu lah.
Ya.
Okay. Terima kasih Dr. Nur Hanimah atas maklumat yang sangat berguna. Ada lain daripada kawan-kawan untuk membantu dua orang pelajar kita ni? Boleh bagi nasihat?
Ini cadangan je lah. Boleh ke dengar suara saya?
Boleh dengar.
It will be more interesting if you can have an interactive punya presentation rather than a one-way presentation. Maksud saya maknanya interaktif tu, let's say for example, macam mana katalah you memberi satu contoh tu maknanya some sort like macam hands-on punya hands-on macam ni dia macam you menunjukkan dia katalah student tu masukkan nilai and then you go step by step. Then it will be dia nampak lebih livelier lah, what I'm trying to say. Kalau yang video yang sedia ada ni, dia lebih quote unquote kaku. Dia tidak nampak livelier. Jadi some interactive element tu kalau boleh di inject in the video, that will be better. Itu pandangan saya lah, kalau boleh diterima.
Ya.
Thank you.
Okay. Terima kasih Prof Daud. Pandangan Prof Daud amat berguna. Jadi Sharifah Nohan dan juga Nurul lain, please take note. Sharifah Nohan ni sekarang berada di Kanada. Sebab baru ni kita ada program di sana. Mereka sekarang, Sharifah Nohan ada di Kanada, mereka Nurul lain ada di sini. Dan InsyaAllah dia sedang melihat YouTube kita pada petang ini. Jadi please take note, Sharifah Noha dengan Nurul lain, tambahkan interaktif elemen di dalam pembentangan tadi. Jika boleh. Terima kasih Prof Daud atas komen yang sangat membantu. Ada lagi mungkin kawan-kawan yang lain boleh share pengalaman yang lalu. Kita masih ada banyak masa lagi.
Saya nak komen sikit lah, bukanlah nak komen, saya just nak beritahu yang saya setuju dengan apa yang diperkatakan oleh Prof Daud tadi. Sebenarnya sebab dia punya the main significant of the project, sebenarnya kalau kita tengok ialah dia punya GUI tu, betul tak? Okay, that is the main significant of the project. Jadi kita nak highlight yang GUI tu. Jadi orang pun yang juri-juri dan yang peserta yang lain-lain, pengunjung yang datang, dia nak tengok apa tu GUI tu, macam mana dia berfungsi. Jadi kalau kita boleh attract orang, terutama juri, kepada significant of our project itu, iaitu GUI tu, dan kita masukkan dalam kita punya video tadilah. Tetapi pada masa presentation nanti, iaitu pada masa IID tu, memang kena sedia adalah dengan laptop dengan GUI tu supaya juri dan pengunjung yang datang, sesiapa yang datang boleh try hands on pada masa tu. Tapi memang seperti yang Dr. Daud cakap, kita highlight juga dalam video tu.
Okay, terima kasih PM Rohana. Okay, jadi saya rasa itu pandangan yang sangat baik daripada PM Rohana. Terima kasih. Ada lagi daripada kawan-kawan yang lain? Tolong beri pandangan untuk menambah baik jika ada. Okey, so kalau tak ada, saya rasa kita tangguhkan dulu kolokium kita pada petang ini. InsyaAllah kita akan buat pada bulan hadapan pembentang yang lain. Kalau ada soalan berkaitan dengan video tadi, boleh terus berhubung dengan Dr. Nurmi. Untuk pembentang terakhir ini boleh berhubung terus dengan saya. Dan terima kasih juga pada Dr. Hanimah kerana membuat pembentangan secara live tadi. Jadi terima kasih semua. Sekian. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you Dr. Agus and all.
Ya, sama-sama.